Alright guys, just to kind of continue our work with the scatter plots, I want to look at number 12 in the exercise set of 4.2. What they've done for us is they've given us a small set of data, and they said to go ahead and plot the points and come up with the equation for the line that fits the best here. So let's see what we have to do. Alright, so here's our xy's, and so now we're asked to go ahead and, so first thing to do is plot them. I know it's kind of a tedious thing, but it's the best way to get a good picture of what's going on is to plot all the points. So let's see what we got going on here. So I made my xy axis here. So our first point was 3, 0. So 3, 0 is right here. We'll do 1, 2, 3, 4. This is 5, 6, 7, 8, 9, 10 right here. Okay, cool. And then up here, 1, 2, 3, 4, 5 is right here, and 6, 7, 8, 9, 10 is right here. Okay, so there you go. All right, so we got 3, 0, and then we got 5, 2 is right here, and we got 7, 3 is right here, and then 9, 6, which is here, and then we have 11, 9, which is up here, thereabouts. And we got 13, 11, which is way up here. So it looks like a pretty good straight line. So which 2 points should we use to kind of to summarize this line? I would say let's use probably this one. Let's just use this one and this one. I say if we drew a line through these 2 points, it would probably be pretty good. That works pretty good. So we're going to go with those 2 points. This point was the point 5, 2, and this was the point, was this 13, 11. So those are our 2 points that we're going to use. And so now our goal here is to now make an equation of this line. So we're going to use these 2 points to make an equation of the line that goes through all this data. So this is kind of old stuff. Hopefully this is a bit of a refresher for us. If not, pay attention. Okay. So we have 2 points. The 2 points we have. So we got point 1 is 5, 2, and we got point 2 is 13, 11. So this is just a basic problem of having to make the equation of a line using 2 points. Well, the first thing we need is a slope. And the equation for the slope, or the formula for the slope, was that m equals y2 minus y1 over x2 minus x1. Hopefully we should, some of this notation should look familiar from when we're using the distance formula. Remember, this is both of these are an x and a y. X and a y. And this is point 1, so it's x1 and y1. This is point 2, so this is x2 and y2. So that's how that works. So if we're going to do this, it looks like we're going to have y2, which is, let's say, 11 minus 2 over 13 minus 5. So what do we get? That's 9 over 13 minus 5. What's that? 8? Yeah, that's 9/8. So that's our slope. When we deal with a slope, best to leave it as an improper fraction. We're going to leave this improper. Okay, so that's our slope. So now we have a slope. It's good for us. Now we get to use the slope-intercept, or the point-slope formula, which looks like this. It's y minus y1 equals m times x minus x1. This y and this x are going to be kind of the leftover things when we have our finished equation. Remember, we're going to have f of x equals mx plus b, or y equals mx plus b. And then y1 and x1, they can really be any x or y in the either point. But we'll use x1 and y1 just to kind of keep things the same. Okay, so let's plug some things in. So we got y minus y1 is 2 equals m. We just found m. M is 9/8. Times x minus x1 is 5. So here's where things get a little nasty, especially with this fraction. Y minus 2 equals, we have to distribute up here. So we're going to get 9/8 x minus 9/8 times a negative 5, let's see, 9 times 5 is 45, so minus 45/8. And then now we can do plus 2 to both sides, so we get y equals 9/8 x, and then we have to add 2 to this. So if I remember how to do this, plus 2, so that's going to be negative 45/8 plus 16/8. People who remember how to use fractions should remember why we're doing this. So what is that? It's negative 45 plus 16. So negative 45 plus 16. Oops. Negative 45 plus 16 is negative 29. So we get negative 29/8. So it's going to be minus 29/8. And there we go. Now this is y equals, remember the way we do it is we do f of x, so that would be f of x equals 9/8x minus 29/8. And when we have these, it's always best to leave the slope as an improper fraction, because now we know if we wanted to graph it, we would go, up 9/8 for the rise over run, and then this is our y-intercept right here. And so this is the equation for this line that we made. Now notice if you had chosen 2 different points, it would given you a different equation. These numbers would have been slightly different if it was a different if we used different points. But we do the best we can, and it's best to look at it, because if we had say we had just kind of randomly chosen 2 of these points, well, we might have got these 2 points. And if we make the line going through those 2 points, well, that's a very different line. See how that works? And if we maybe chosen these 2 points, that's also a very different line. So it's always best to look at them all, look at the whole scatter plot, pick the 2 points that kind of make the best line through it, and then use this process to first find the slope, and then find the equation of the line in the slope-intercept form. Okay? All right. Good luck with that, guys. Hope that clears some things up.